I'm Dr. Lutz Miri, Associate Professor in the Department of Computer Science and Engineering. I'm going to take the topic Model Driven Test Design for the subject Software Testing and Automation. This is the vertical elective for third year, 6th semester CSE students. First, we'll see what is Model Driven Test Design. What is a thirsty? It's one of the thirsty areas in software testing. So, no other engineering field builds products as complicated as software. The term correctness has no meaning. Is a building is correct? Is a car correct? Is a subway system correct? Like other engineers, so we must use abstraction to manage complexity. This is the purpose of the model driven test design process. The model is an abstract structure. So software testing foundation, so testing can only show the presence of failures, not their absence. So not all inputs will trigger a fault into causing failure. So fault and failure model RIPR, the four conditions are necessary for a failure to be observed: reachability, infection, propagation and reveal. That's why it's called as RIPR, reachability. The location or locations in the program that contain the fault must be reached. Infection, the state of the program must be incorrect. Propagation, the infected state must cause some output or final state of the program to be incorrect. Reveal, the tester must observe part of incorrect portion of the program state. Traditional testing levels will be having system testing, acceptance testing, integration testing. Likewise it goes on. So system testing will test the overall functionality of the system. Acceptance testing is the software acceptable to the user. Is it acceptable? Can be acceptable by the user. So the main class P module testing, that is called as developer testing. It's a test each class, each file, each module and component. Integration testing is the test how modules interact with each other. Class A method MA1, method A2, class B method B1 to B2, unit testing, developer testing, test each unit individually. This view obscures underlying similarities. The test design is a process of designing input values that will effectively test the software. Test design is one of the several activities for testing software. Mostly technically challenging. So what are the types of test activities? So we'll see one by one. So testing can be broken into four general types of activities: test design, test automation, test execution and test evaluation. Each type of activity requires different skills, background knowledge, education and training. No reasonable software development organization uses the same people for requirements, the same people for design, the implementation, integration and configuration. So each and every people requirement will have some people. So design people will be different, implementation people will be different, then their knowledge level is also varies. So based on this we'll be having two criteria, two categories. First one is criteria based and human based. We'll see one by one. So test design, criteria based. So design test values to satisfy the coverage criteria or other engineering goal. This is the most technical job in software testing. It requires knowledge of discrete mathematical programming. Testing requires much of the traditional computer science degree. So this is intellectually stimulating, rewarding and challenging. Test design, this is analogous to or similar to software architect on the development side. So using people who are not qualified to design test is a sure way to get ineffective test. So human based. They design test values based on the domain knowledge of the program and human knowledge of testing. So this is harder than the criteria based one. It requires knowledge of domain. So testing knowledge is needed, then user interface knowledge is needed. It requires almost no traditional CSA background. So domain of the software is essential. So an empirical background is very helpful, biology, psychology. A logical background is also needed. So law, philosophy or mathematics. This is intellectually stimulating, rewarding and challenging, but not typical to CS. The design steps involved in that is criteria, refine requirements, model, test requirements, generate analysis, test requirements, and domain analysis. Refined requirements, test design you can model, you can have the test requirements, abstraction level, raising your abstraction level. Make the test design much easier. Example is, you can have the JavaScript, it will be searching by the value 45321. If not present, it will return -1. Thank you.